Okay, in this video, I'm going to demonstrate piecewise function. So I want you to, I want you to take notes while you watch the video on the worksheet that I left for you. So when we're doing a piecewise function, what that means is you're graphing parts of functions over specific domains. So this first function, this is not a piecewise function. First function, f of x equals 4. That's the same thing, remember, as y equals 4. That's just a horizontal line through the value y equals 4. Second function is the horizontal line through y equals -1. The third one is as an example of a piecewise function. So between the points -6 and -1, we're only going to graph our f of x function. They both have brackets, therefore we need solid points where we start there. So at -6, I'm going to put a solid dot at +4. At -1, I put another solid dot, and then I connect my function between those two dots. So it looks the same as this function, but it's only between the values of -6 and -1. Then I jump down to g of x, which is this function. And I'm only listing between these x values. So I have a parentheses at -1. So at -1, -1, I'm going to put an open circle because it's a parentheses. And I go all the way to 8 and put a solid circle, connect, and this is your piecewise function. You probably want to use a straight edge, a ruler, or something to help you make your graph look good, not like my line that I just drew. The next function, we have just your quadratic parent function. So I'm going to plot my points that I need. I'm going to try, I think this is the smallest it will get. My points seem pretty big. So I'm at 0, 0. I'm at 1 for 1 and -1. At 2, I'm at 4. And at -2, I'm at 4. Negative x squared, remember, just flips that across the x-axis. So it goes this way. Now I need to look at where I need to graph this. From -infinity to 2, I'm going to look just at this function. So I go over here, and if I plug in 2, I'm at 4, and I want a solid dot because that is a bracket. Well, before then, I know I have a point here, and here, and here, and another one here. So I'm going this way. And I'm going to keep going up because I want to go to -infinity on the x. Then I'm going to jump down to this function, which is -x squared. So at 2, I was down at -4. So I'm going to go to -4, and I'm going to put an open circle because it's a parentheses. Well, if I want to find out where I go from there, I know I keep going down. If I plug in the next value, 3, well, I get -9, which isn't on my graph, but I know that I'm going to end up way down there. So there is the graph of that piecewise function. Let's look at the next one. X cubed. I'm going to put all my values, which remember I said we're working on remembering exactly where those go. Cube root of x goes like this. And I want to find out what I'm graphing and where. From -2 to 0, I'm plotting f of x. So -2 to 0, that's the part I'm graphing on my graph. I want an open circle at -2. I want a solid circle at 0, and I can put my other point there. Then from 0 to 8, I want to go here. Well, if I plug in 0, I should have an open circle, but I've already got a dot there, so I don't really have to worry about that part. Then I go to 1. And then I go to 8, which I know my graph does that. And I want an open circle at 8 because I have a parentheses. Now I've got another quadratic that's been shifted, and that x plus 3 means it went left 3 units. So it's my parent function just shifted to the left. Everything else is the same. So it goes like this. G of x equals 5. That's just a horizontal line. So I go look at my piecewise. Between -5 and -2, I want to graph my quadratic. So if I go over to my graph, I can look at -5, where it is, -5, 4, and I want an open circle because it's a parentheses. And then at -2, I'm at 1, I want another open parentheses. And I know based on how my graph looks over here that I want to go here, here. So it has to go like this. Then I'm going to jump to my other graph. And between -2 with a solid circle, -2, and I'll be at 5, to 7, another solid circle, I am just the horizontal line, y equals 5. Okay, 2 more on this section. X to the 2/3 minus 3. This has been shifted down 3 units. So I'm going to do my parent function, points, figure out how that goes. This is my radical or square root function, which has gone right 1, up 3. So right 1, up 3 is my first point, and then everything else follows after that. So what parts am I graphing? I'm graphing my x to the 2/3 minus 3, which is cube root squared, essentially, between -8 and -1. I know at -8, I'm here and I want a solid circle because it's a bracket. At 1, I'm here, and then I'm going to fill in the points in between. I know I'm here and here, so it goes like this. Well, then I jump here, and I want to follow that graph. So at 1, I'm at 3, and I want an open circle. Then I follow my points, and I'm going to infinity, so I want those to go that direction. Here I have an absolute value that has been reflected and shifted. So I know my initial point can't be reflected across the x-axis, so all I'm going to do is move it left 5 and up 4. Left 5, up 4. And then I'm just going to follow the pattern of my absolute value function. Okay, every other point, you don't have to shift and reflect every individual point. It will take that pattern every time. Here, I've got a cubic function that's been shifted right 2. I'm going to go right 2 and put a dot. Then I put my other points that follow after that. And just experience with these graphs will help you eventually remember what the pattern is, where the points go each time. So from -infinity to 1, I'm looking at this graph. Well, at 1, I end up, if I plug in 1, I know it's going to keep going down here. But I could also plug it in. -1 plus 5 plus 4. So I get -6 plus 4, which is -2. So I know at 1, -2, I've got a solid dot because it's a bracket. So I'm going to graph every other point I see on there all the way until I get to my vertex point. So just follow so I can see the pattern. Then I'm going to go to this one. and I look at this. So I'm going from 1, where was I at 1? I was at -1 right here. And I'm going to put an open circle because that is a parentheses. And then I follow the pattern the rest of the way. And I get an arrow because I'm going to infinity. So next, I'm going to look at the examples where I give you a piecewise function, or I give you the graph, I'm sorry, and you are going to tell me what the actual functions are. Well, I've got two different graphs here. We'll start with writing f of x equals and putting my brackets. Well, I know this first one, I'm going to do a lot of changing of pens. First one is this one. Second one is here. I got to figure out where that's going between, and then I'll jump in and figure out what the function is. Well, from here, you've got an arrow on your paper. I'm going from -infinity all the way to -2. What is your function at -2? Along here. You've got 1, 2, 3. It's just y equals 3. It's just a horizontal line. And I have parentheses here because I have an open circle right there. So let's go to our green graph. You've got an arrow on your page here as well. You've got a linear function, and I know it's starting at -2 with a solid circle, and it's going to positive infinity. Remember, these values over here are x values. So I want to figure out my linear function. Well, you've got a slope of -1, and it crosses the y-axis at 1, so -x plus 1. That's slope-intercept form, which you learned way back in Algebra 1. Okay, let's look at the next problem. Here, we're going to have 3 intervals, because I can see that my graph is here, here, and there. So let's figure out what those would be. So you've got a left arrow, that's going to be -infinity, and I'm going all the way to -1 with a solid circle. Then I'm going from -1 with a parentheses because it's open, all the way to 2 with another parentheses. Then I start again at 2 with a solid circle, and I go to infinity. So you want to look at this yellow graph and you figure out what kind of function is it. Well, it is a quadratic that's been flipped. So it's been flipped across the x-axis, so I'm going to start with a negative. It's been shifted left 1 unit, and it moved, it's been shifted left 2 units. I was looking at that first point instead of the vertex point. So it's been shifted 2 units, and then there's my vertex, and up 1. I'm looking at the vertex value. So that point right there is what I'm looking at to form my equation. My green line is a horizontal line, so it's just -1. It is constantly -1 between the x values of -1 and 2. And then I'm going to go to my blue line, which is a square root function. And my starting point has moved left 2, which remember is the opposite, up 1, so it's +1 on the outside. Let's look at the next one. We've got 3 functions again. Okay, there's an arrow, arrow. I know I'm going from -infinity to 0. Let's go ahead and figure out what that equation is. It's a horizontal line at y equals 3, so we just get a 3 there. Then from 0 all the way to 4, and on both ends, I have solid dots. You've got a linear function with a negative slope, and it looks like the slope is -1, and a y-intercept of 0, so I just put -x. And then finally, I'm going from 4 with an open circle to infinity because you have an arrow right there. And you want to figure out what kind of function is that one. Well, that appears, even though we only have 1 point, it's a quadratic. So this appears to be the vertex. Then it went up 1 over 1, then up 3 over 1. So it's been shifted